Okay, in this class I am going to talk about the normalized radial functions, okay, of for the hydrogen atom. And in the last class we established that the radial function, okay, or solution for the radial part of the radial part of the equation means R equation, okay, and the solution is equal to RNL R N L R is equal to rho raised to L L n plus L 2L plus 1 2L plus 1 rho e raised to or exponential minus rho divided by 2, okay, or we can write like rho is 2 z r divided by n a0, okay, this is rho. So we can write that the solution is 2zr 2zr divided by n a0 raised to l l n plus l 2l plus 1 and 2zr divided by n a0 exponential minus zr divided by n a0. Okay, so this is the solution of the R equation, that is R and L R. Here n and L are given as a subscript because this equation or this expression or this R and L R depends upon n and L, right? You can see n and L here. We already saw the nature of n and L in the last video. Okay, and here, even if this is a solution of the R equation, this is not a normalized solution. So we have to introduce one normalization factor n here, and the value of n can be obtained from the condition that integral 0 to infinity, okay, n square, then r n l r square, okay, uh, d tau is equal to 1. It means that we are integrating the square of this function, this wave function, over the entire region, means from 0 to infinity, okay, and the probability for this is actually the probability to find that particle between 0 to infinity, right, defined by the R part of the wave function, okay, that is equal to 1, okay. So from this condition we can get the value of n, and the value of n is equal to minus of 2z divided by n a0 rise to 3 n minus l minus 1 factorial divided by 2n into n plus l factorial, n plus l factorial, the whole cube, okay, whole cube, the whole rise to 1 divided by 2, okay, 2 is divided by n is equal to whole cube into n minus l minus 1 factorial divided by 2n into n plus l factorial, the whole cube, the whole raised to half, that is equal to n, okay. So this is a normalization factor in the for the R equation. And when we are introducing the normalization factor in this equation, we get the normalized R function. And now I am going to find out the normalization factors for different sets of n and l. Okay, normalization factors for different sets of n and l. So let me take n is equal to 1 and L is equal to 0. Okay, when n is equal to 1, the only one possible value of L is equal to 0. And in that case, the normalization factor n10 is equal to minus of 2z by na0, right? 2z by na0. N is equal to 1 here. So we can write like 2z divided by a0, 2z by a0, the whole cube into n minus l minus 1. What is n minus l minus 1 here? 1 minus 0 factorial divided by 2n into n plus l factorial. That is 2n in this case is equal to 2 into n plus l factorial is equal to 1 factorial itself, right? 2 into 1 factorial the whole cube, okay, raised to half, raised to half. So that is equal to minus of 2z divided by a0 the whole cube into 1 factorial, that is equal to 1 divided by 2, okay, 1 by 2, so all raised to half, and that is equal to we can write minus 2, because 2 cube, we can take 2 cube here. 2 cube divided by 2 is equal to 2 square, that is equal to 4, and 4 raised to half is equal to 2. So that is equal to 2, but we have minus also here, minus 2 into, what is remaining here? Z by a0 raised to 3 divided by 2. Okay? 3 into 1 by 2, that is equal to 3 divided by 2. Okay, so this is the normalization factor corresponding to n is equal to 1 and l is equal to 0. Okay, now we can calculate the normalization factor corresponding to n is equal to 2 and l is equal to 0. Okay, so n20 is equal to minus of 2z divided by a0, and 2z divided by na0, that is equal to 2z divided by 2z divided by 2a0 the whole cube into n minus l n minus l minus 1 factorial, that is 2 minus 0 minus 1 factorial divided by 2n, that is equal to 4 into n plus l factorial, that is equal to 2 factorial the whole cube, okay, the whole raised to 1 divided by 2, okay. So that is equal to minus of z by a0 the whole cube, okay, the 2 minus 1 factorial, that is 1 factorial, that is 1 divided by 4 into 2 factorial. 2 factorial is 2. 2 cube is equal to 8. So 4 into 8. Okay. So we can write it like that is equal to minus of z by a0 raised to 3 into this one. Actually is, we can write it like 1 divided by 4 into 8 is nothing but 1 divided by 4 is 2 into 2 into 8, right? 2 into 2 into 8. 2 into 2 into 8. So 2 into 2 into 8. So this 2 into 8 is equal to that is equal to 16. So this is equal to 16. So the root of 16 is equal to 4. So we can write it like 4 here. So minus 1 divided by 4. And what is remaining here? Root 2. 4 root 2 into z divided by a0. The whole cube raised to, whole cube into 1. Whole cube raised to 1 by 2. That is equal to raised to 3 by 2. Okay. So minus 1 by 4 root 2 z by a0 raised to 3 by 2. That is the n20. Normalization factor corresponding to n is equal to 2 and l is equal to 0. Now let me go for the next one, that is the normalization factor corresponding to n is equal to 2 and l is equal to 1. N is equal to 2 and l is equal to 1. And in that case n21 is equal to 2z by na0, that is 2z divided by 2a0 the whole cube into n minus l minus 1 factorial, 2 minus 1 minus 1 factorial divided by 2n, that is equal to 4 into n plus l factorial, that is 3 factorial, right? 4 into 3 factorial the whole cube raised to 1 by 2. Okay, that is equal to um, we have a minus sign here. So minus of z by s0 the whole cube into 2 minus 1 minus 1 5, that is 0 factorial, that is equal to 1 divided by 4 into 3 factorial. 3 factorial the whole cube. 3 factorial is 6 and the whole cube is 6 into 6 into 6. So we can write it like 4 into 6 into 6 into 6. So all raised to 1 by 2. Okay, and this is 4 into 6, 24. 24 into 6, 144. So altogether this is 144. Okay, the root of 144 is equal to 12. So therefore we can write like the root of this quantity is 12 root 6. So let me write it like minus of 1 divided by 12 root 6, then z by s0 raised to 3 by 2. So that is n to 1. Minus 1 by 12 root 6 z by s0 raised to 3 by 2. So I have calculated the normalization factors for 3 sets of Conden numbers. N is equal to 1, n is equal to 0, n is equal to 2, n is equal to 0, and n is equal to 1. N is equal to 2, n is equal to 1. Now, let me make the associated Laguerre polynomial corresponding to this set of Conden numbers. Associated Laguerre polynomials. So, associated Laguerre polynomial that is LKPX. Okay, LKPX is equal to, what is LKP? What is the definition of LKPX? D raised to P by dx raised to P of LKX. LKX, where LKX is the Laguerre polynomial and LKX is defined as d raised to x into d raised to k divided by dx raised to k x raised to k e raised to minus x. Okay, so that is LKX. So in our case we have n is in place of LKX we have L, n plus L, 2L plus 1 row, right? L, n plus L, 2L plus 1 row. So in our case k is equal to n plus L. In our case k is equal to n plus L and p is equal to 2L plus 1, right? Okay. So for different values of n and L, now I am going to calculate this L, n plus L, 2L plus 1 row. So let us take the first example, that is n is equal to 1 and L is equal to n is equal to 1 and L is equal to 0. N is equal to 1, L is equal to 0. Okay, and in this case n plus L is equal to 1 plus 0, that is equal to 1, and 2L plus 1 is equal to, that is also equal to 1. So L11 row is equal to, we can use this one, LKPX is equal to this. So L11 row is equal to d by d row of L1 row, and L1 row is equal to that is equal to e raised to row d by d row of x raised to k e raised to minus x. In our case it is row raised to k. K in our case is that is this one, right? Row raised to 1 e raised to minus row. So we can write row raised to 1 row e raised to minus row. Okay, so this is equal to L1 row is equal to this one, d by e raised to row into d by the row of row e raised to minus row, that is we can write like e raised to row into first derivative of this one, row e raised to minus row. So we have to take the derivative of product of two functions, right? So first function, that is rho, into the derivative of the second, that is e raised to minus rho into minus 1 plus second function e raised to minus rho, the derivative of the first, that is equal to 1. So we can write it like this. Okay. So that is equal to e raised to rho multiplied with e raised to minus rho, that is equal to 1. So we have a rho into minus 1, that is equal to minus rho minus rho. Then here e raised to minus rho and e raised to rho is, they are cancelled. So what is remaining is plus 1. Okay. So minus rho plus 1. So from this one, L11 rho is equal to d by, so from here. Okay. So this is equal to d by d rho of, sorry, that is equal to d by d rho of L1 rho. L1 rho is minus rho plus 1. Minus rho plus 1. So d by d rho of minus rho is equal to minus 1. Minus 1. And of this one is equal to 0. So the answer is minus 1. Okay. So L11 rho is equal to minus 1. So let us remember this. This is L11 rho. And now we are moving to the next value of n and L. Okay, next two values of n and L. Now that is n is equal to 2 and L is equal to 0. Okay, n is equal to 2 and L is equal to 0. And in this case, n plus L is equal to 2 and 2L plus 1 is equal to 1. Okay, so we have to find out L21 rho. L21 rho. L21 rho is equal to d by d rho of L2 rho, right? L2 rho, where L2 rho is equal to e raised to rho of d square by e raised to rho into d square by d rho square of rho square e raised to minus rho, right? E raised to minus rho. So that is equal to e raised to rho of d square by d rho square of this one. That is we have to take d by d rho of first derivative of this one. Okay, d by d rho of first derivative of this, that is equal to rho square e raised to minus rho into minus 1 plus e raised to minus rho into 2 rho, right? So that is equal to e raised to rho of then we can write it like e raised to rho into minus 1. Okay, minus 1. Minus 1 is coming from here of d by d rho of this one, that is rho square first function into e raised to minus rho into minus 1, that is derivative of the second, plus e raised to minus rho, that is second function, into derivative first, that is equal to 2 rho. Okay, 2 rho plus now the derivative of this one plus 2 into derivative of e raised to minus rho into rho, that is first function, that is e raised to minus rho into derivative of rho, that is equal to 1 plus second function, that is rho into derivative of first function, that is e raised to minus rho into minus 1. Okay, and all this is multiplied by e raised to rho. So that is equal to e raised to rho into then minus 1 into minus 1, that is equal to plus 1. So that is rho square e raised to minus rho plus minus 1 into this one, that is minus 2 e raised to minus rho, or we can write rho e raised to minus rho, then 2 e raised to minus rho 2 e raised to minus rho plus 2 into minus 1, that is equal to minus 2 rho e raised to minus rho. Rho e raised to minus rho. Okay. And that is equal to now we are multiplying the e raised to minus rho with every of these terms, that is rho square, okay, minus 2 rho, then plus 2, then minus 2 rho, okay, that is equal to rho square minus 4 rho plus 2. Okay, so that is L2 rho. Now we have to take d by d rho of L2 rho. So d by d rho of L2 rho is equal to, let me take the next page. So d by d rho of L2 rho, that is L21 rho is equal to d by d rho of L2 rho. L2 rho is equal to rho square minus 4 rho plus 2. Okay. So that is equal to 2 rho minus 4 plus 0. Okay. So the value of L21 rho is equal to 2 rho minus 4, and rho is equal to 2 is a dot divided by Na0. So we can write it like 2 rho minus 4, that is equal to 2 into 2 is a dot divided by Na0. N in this case is equal to 2. So 2 A0, okay, minus 4. Okay, that is equal to 2 into ZR divided by A0, 2 into ZR by A0 minus 4. Okay, so that is L21 rho. 2 ZR divided by A0 minus 4. So let us remember this equation also, this result also. Now we are going for the last one, that is for n is equal to 2 and n is equal to 1. N is equal to 2 and L is equal to 1. So in this case, n plus L is equal to 2 plus 1, that is equal to 3, and 2L plus 1 is equal to 2 plus 1, that is equal to 2 plus 1, that is equal to 3. Okay. And therefore we have to find out L33 rho, that is LKPX, okay, L33 rho, that is equal to d cube by d rho cube of L3 rho, Now we have to find out L3 rho. So let me do this in the next page. L3 rho is equal to L3 rho, that is equal to e raised to rho, okay, of d cube by d rho cube of rho cube e raised to minus rho cube e raised to minus rho. Okay, and that is equal to e raised to rho of d square by d rho square of first derivative of this one. Okay, d square by d rho square of rho cube e raised to minus rho into minus 1 plus e raised to minus rho and 3 rho square. Okay, 3 rho square, and that is equal to e raised to rho of minus 1 into d by d rho of rho cube, that is, I am going to take the first derivative of this one. Okay, d by d rho of rho cube e raised to minus rho into minus 1. This minus 1 is already taken out here. Okay, e raised to minus rho into minus 1 plus e raised to minus rho into 3 row square. Okay, 3 row square plus, now we have 3 here, so plus 3 into d by d rho of first derivative of this one. So let me write it in the next line. That is plus 3 into d by d rho of this, okay, that is e raised to minus rho square. So the first function is e raised to minus rho. The derivative of the second is 2 rho plus second function, that is rho square. The derivative of the first, that is e raised to minus rho into minus 1. Okay. Okay. Yeah. This is equal to minus 1 e raised to rho multiplied by minus 1 into minus 1, that is equal to plus 1 d by d rho of rho cube e raised to minus rho, that is first derivative of rho cube e raised to minus rho, that is rho cube, that is first function, e raised to minus rho, that is derivative of the second, into minus 1, right? So plus second function e raised to minus rho into derivative of the first, that is 3 rho square, okay, plus and now minus 1 into 3, so we have to write minus 3 here, so that is minus 3 into d by d rho of e raised to minus rho square. Okay, so minus 3 into d by d rho of e raised to minus rho square, that is e raised to minus rho into 3 into 2 rho plus second function, that is rho square, into derivative first, that is e raised to minus rho into minus 1. Okay, minus 1 plus 3 into d by d rho of this one, 3 into 2, that is equal to 6. So 6 into 6 is a common factor here, and 6 into d by d rho of this one, e raised to minus rho, that is e raised to minus rho into 1 plus second function, that is rho into derivative first, that is e raised to minus rho into minus 1, okay, plus 3 into minus 1, that is equal to minus 3 into derivative of rho square e raised to minus rho, that is rho square e raised to minus rho into minus 1 plus e raised to minus rho into 2 rho. Okay, so that's it, and that is equal to now e raised to rho is multiplied with every term here, that is e raised to rho into e raised to minus rho, that is equal to 1. What is the remaining is a rho cube into minus 1, that is minus rho cube, okay, plus e raised to minus rho and e raised to rho is cancelled. What is remaining is plus 3 rho square, and now minus 3 into 2 rho, that is equal to minus 6 rho, then minus 3 into minus 1, that is equal to plus 3 rho square, and 6 into e raised to minus rho, then this is a plus 6 and 6 into minus 1, that is minus 6 rho, then minus 3 into minus 1, that is plus 3 rho square, and minus 3 into 2, that is equal to minus 6 into rho. Okay, so that is minus rho cube plus 3 rho square minus 6 rho plus 3 rho square plus 6 minus 6 rho plus 3 rho square minus 6 rho. Now we have L3 rho. Now we have to find out the L33 rho. And here we have what is L33 rho here? L33 rho is equal to dq by d rho cube of L3 rho. And we have L3 rho here. So now we have to take the third differential of this L3 rho. Okay. So in the next page I will write that is L33 rho is equal to d cube by d rho cube of L3 rho. Okay. L3 rho. And L3 rho we already know. So third differential of this one. So I am not going to write all these things here. I am going to take the third differential because I know which are the terms which are going to be cancelled, because this is a rho square. So when we are taking the third differential, this term will be cancelled. This will rho raised to 1. That will be cancelled. Rho square. So all these terms will be cancelled. Only we will get some appreciable value only from the rho raised to cube term. അല്ലേ, നമ്മൾ തേർഡ് ഡിഫറൻഷ്യൽ ആയിട്ട് എടുക്കുന്നത്. അതുകൊണ്ട് ഈ ടേമുകളുടെ എല്ലാം തേർഡ് ഡിഫറൻഷ്യൽ എന്തായിരിക്കും? 0 ആയിരിക്കും. കാരണം അതിന്റെ റോയുടെ പവർ എന്ന് പറയുന്നത് 3-ൽ താഴെയാണ്. ഇവിടെ റോയ്ക്ക് 3 എന്ന് പവർ വരുന്നത് ഈ ഒരു ടേമിൽ മാത്രമേ ഉള്ളൂ. അപ്പോൾ അതിന്റെ മാത്രം ഡിഫറൻഷ്യൽ എടുത്താൽ മതി. ഓക്കെ, ബാക്കി എല്ലാം 0 ആയിട്ട് പോകും. ഓക്കെ, സോ തേർഡ് ഡിഫറൻഷ്യൽ ഓഫ് മൈനസ് റോ ക്യൂബ് ആണ് നമുക്ക് എടുക്കേണ്ടത്. So we can write like that is equal to d square by or d cube by d rho cube of minus rho cube that is equal to d square by d rho square of first derivative of this one, that is equal to minus 3 rho square. Okay, 3 rho square, and that is equal to d by d rho minus of d by d rho of 6 rho, and that is equal to minus 6. Okay, so the answer of L33 rho is equal to minus 6. Now we have all the associated Lagrange polynomial. Okay, we have the normalization factors and also we have the associated Lagrange polynomial. Okay, associated Lagrange polynomial and the normalization factor. Let me find out where we started. Okay. Okay, now we have the normalization factor n and the associated Lagrange polynomials also. Okay, associated Lagrange polynomials also. So now we substitute for n and L in this equation, and then we will get the complete normalized radial function. So the normalized radial function is equal to, and we have to find out the normalized radial function for different values of n and n. So let me calculate the normalized radial functions. Normalized complete radial functions. Complete radial functions. Okay, you can find out for n is equal to 1 and n is equal to 0. That is R10R. That is equal to n in this case is equal to, we already established that n in this case is minus 2 z by a0 raised to 3 by 2. Z by a0 raised to 3 by 2. Then 2zr divided by n0 raised to L. 2zr divided by n a0 raised to L. L in this case is equal to 0. Then in this case the associated Lagrange polynomial is equal to minus 1, and then exponential minus zr by a0, minus zr divided by a0. Okay, that is equal to minus 1 into minus 2, that is equal to 2 into z by a0 raised to 3 by 2. Okay, z by a0 raised to 3 by 2 exponential this raised to 0 is equal to 1 exponential minus zr by a0, zr by a0. So this is the R10R, normalized R10. This is one state. L is equal to n is equal to 1, L is 0, L is equal to 0 represents one state. Okay, in that state the radial function is equal to 2 z by a0 raised to 3 by 2 exponential minus ZR by S0. Like that, now we can find out R20R also. R20R. So R20R is equal to N in this case. What was N in this case? Minus 1 by 4 root 2, right? Minus 1 by 4 root 2. Z by S0 raised to 3 by 2. Z by S0 raised to 3 by 2. And now what was the value of this one? ZR by S in 2ZR by NS0 raised to 0, that is equal to 1, because L is equal to 0 here. So ZR by A0 raised to 3 by 2, 2ZR by NA0 raised to 3 by 2 raised to 0. 2ZR by NA0 raised to 0, that is equal to 1, 0, 1 into what is the associated Lagrange polynomial in this case? That is equal to into associated Lagrange polynomial 2 ZR by A0 minus 4. Okay. 2 ZR by A0 minus 4. We already did this, right? Exponential minus ZR by NA0 minus ZR by NA0. NA0 in this case is 2A0. Okay, 2A0. And that is equal to minus 1 divided by 2 root 2. Okay. Because we have a 2 as a common factor here, we can take this 2 out. Okay, then it will be 2 into ZR by A0 minus 2. So that 2 and 4 will be cancelled, and we have a 2 in the denominator. So minus 1 by 2 root 2. Then Z by A0 raised to 3 by 2 into this 2 is already taken out. What is remaining there is ZR by A0 ZR by A0 minus 2, right? ZR by A0 minus 2. Okay. Then exponential minus ZR by 2A0. Okay. So we can write it like, maybe you can reverse this sign just by taking 2 minus ZR by A0. Then in that case, we can write like 1 by 2 root 2 Z by A0 raised to 3 by 2. Then 2 minus ZR by A0, because we took 1 here instead of minus 1. So we can write like 2 minus ZR divided by A0 exponential minus ZR by 2A0. ZR by 2A0. Okay. So that is R20R. Now we are going to find out R21R. R21R. R21R is equal to, in that case, the normalization factor is minus 1 divided by 12 root 6, right? Minus 1 by 12 root 6. Z by A0 raised to 3 by 2. This was the normalization factor. Now, rho raised to L, or 2ZR by NA0 raised to L. In this case, 2ZR by NA0 is 2A0 raised to L. L is equal to 1 here. Okay. L is equal to 1. So, into associated Lagrange polynomial, the last one we obtained, that is equal to minus 6. Okay. Into minus 6 into exponential minus ZR by 2A0. ZR by 2A0. That is equal to 1 by 2 root 6. Sorry. 2 root 6. That is why it is minus 1 by 2 root 6. We have 6 and 12 cancel here, and 2 is here. Okay. And 1 by 2 root 6. and minus 6 and minus 1, that is, so that is equal to plus, so plus 1 by 2 root 6, and z by a0, z by a0 raised to 3 by 2, then 2 zr by 2 a0, that is zr by a0, zr by a0, okay, exponential minus zr by 2a0, okay. And now what we can do is we can take this z by a0 from here, from this term, and then z by a0 raised to 3 by 2 into z by a0, that is z by a0 raised to 5 by 2. So we can write it like 1 divided by 2 root 6 into z by a0 raised to 5 by 2. Then what is remaining here? R exponential minus zr divided by 2a0. Okay, so that is R21R. Now we have the normalized R21R also. So here I have obtained the three of these R functions for different sets of n and n. And now you can look at these R functions and see this R10R. Here it has an exponential minus zr by a0, and when r is equal to 0, it will have its maximum value, right? And when r is increasing, then it will have an exponential decrease, because exponential minus zr by a0. When r is equal to 0, this is exponential 0, and when r is increasing, exponential 0 means 0 is to 0, that is equal to 1, and this term will start to decrease immediately, because when r is increasing, then this is exponential of a minus quantity, right? So it will start decreasing suddenly, exponentially decrease. So when we are plotting this function, we will get a plot like this. Okay, let me plot this function. So if I am plotting this like this, we take an axis here. Okay. So when I am plotting this function here, that is R10, it will have its maximum value when r is equal to 0. Okay. Sorry. And as r is decreasing, its value will exponentially decrease. Okay, it will go like this. It will go like this. Okay, my this curve is not very nice. You can you can have very nice curves also. Okay, something like this. Sorry. Okay. So as r tends to infinity, the term tends to 0. Okay. So this is how the curve will look like. Okay. And when we are going to the next function, that is, this is R10 function. And when we are going for the next function, that is R20 function, in that case, you can see that this is the function. Here, we have 2 minus zr by a0, right? And when this 2 zr by a0 becomes, zr by a0 becomes 2, in that case, then this term will vanish. So at a particular for a particular value of r, this term will become equal to 0, and as r increasing, then it will again increase, then it will go like this. So if you are plotting this one, we will see that at a midpoint, okay, at a certain value of r, it will come to 0. Okay, if you are taking the entire expression the atomic units, and then you can take a0 as 1, and in that case z for hydrogen atom z is equal to 1, and in that case, in the case of hydrogen atom, if you are taking the r in atomic units, then when r is equal to 2, in that case 2 minus 2, that is equal to 0, it will become 0. Okay, I will explain about the atomic units in another video. Okay, so you have to find out that you have to understand that at a particular value of r, this term will become 0, and the plot will be like this. Okay, and this is for r20. Okay, and when we are coming to the next function, here we cannot see that there is no any term like that, like 2 minus or some number minus. Okay, if a term like this here, then at a particular value of r, it will become 0. Here also we cannot see some term like that. So if you are plotting this function, okay, if you are plotting this function, you can see that it will initially increase. Okay, initially increase because there is an r term here, so it will initially increase, and when after a particular value of r, this exponential function become prominent. Okay, then you can see that it will start decrease. Okay, so its plot will be something like this. Will be something like this. Okay, and this is for r30. Okay, and actually n is equal to 1, n is equal to 1, L is equal to 0 corresponds to s orbital. N is equal to 1, L is equal to n is equal to 2, L is equal to corresponds to 2s orbital. This corresponds to 1s, this corresponds to 2s, and n is equal to 2, L is equal to 1 corresponds to 2p orbital. Okay, and therefore you can call this as the 1s, and therefore this as the 2s, and this as the 2p. Okay, these s p terms actually comes from the conventional spectroscopy. Okay, for example, it comes from like something like a sharp, precise, etc. Okay, so you can see that in the case of the 2s orbital, there is a node. Okay, this node means the function becomes 0. The function's value becomes 0. See, the function decreases and the function gets 0 value in this axis. Okay, then it goes negative, and then it is again increasing. So function becomes 0 here. It means that it has a nodal point here. So if you are checking into the number of nodes, you can see that the number of nodes is equal to n minus L minus 1. This will be equal to the number of nodes. So in the case of 1s orbital, n minus L minus 1 is equal to 1. In the case of 1s orbital, it is equal to 1 minus 0 minus 1, that is equal to 0. Okay. In the case of 2s, it is 2 minus 0 minus 1, that is equal to 1, and in the case of 2p, it is 2 minus 1 minus 1, that is equal to 0. Okay, so there is no node in the case of 1s, and there is no node in the case of 2p, but you will see one node in the case of 2s. Okay, one node in the case of 2s. Okay, so this is what you have to understand from here. So now we have only the radial part of the wave function. I have plotted only the radial part of the function. Okay, you know that there is a p part and f part also for the wave function, and this is only a partial wave function, and the complete wave function will be obtained when we are multiplying this r function with the p and the f functions. Okay, so that we will do in the next class, and there we will see the complete wave functions and a plot for these complete wave functions. It is actually difficult to plot the complete wave function because it contains three variables, or three r, theta and phi. So it is very difficult to plot in a two-dimensional space, but we will make some conclusions based on our mathematical understanding. Okay, that we will do in the next class. And I hope you understood this one. And now what you can do is you can make the R functions for n is equal to 3, n is equal to 0, n is equal to 3, n is equal to 1, and n is equal to 3, and L is equal to 2. Okay, so this corresponds to 3s, this corresponds to 3p, and this corresponds to 3d sets of orbitals. Okay, so you can take these any different values of n and L, and then you can derive the R, NL, R values for these sets, and I will upload the values in a link in the as a link in the description of this video. Okay, you can check the description of this video. There will be a link, and there I will upload the calculation of these one. First you do it yourself, and then check the link whether you have done it correctly or not. Okay, I will take a few days to upload it, and before that you can complete your assignment, and when I upload it you can check whether your values are correct or not. Okay, or the expressions that you have obtained there are correct or not. Okay, so this is assignment for you. Okay, so I hope you understood all this, and we will continue with the other part of the wave function, and it will be very interesting. There we will see the shape of the orbitals and all, or the orientations of the orbitals, and these are going to be very interesting. And thank you for watching, and stay tuned.